Welcome back, guys. Patrick here, moving on with the discriminant section. For what values of m does the quadratic y equals 2x squared plus m over 3x squared plus 2mx plus 2m plus 7 have 2 x-intercepts, 1 x-intercept, and no x-intercepts? So before watching this one, if you didn't watch the video beforehand, highly recommend you do, because it's very similar to this. This one's a little bit more tricky, but the process is the same. So I'm going to go through it a little bit quicker in this video. So let's rewrite what we have here. We have this weird looking quadratic, 2x squared plus m over 3x squared plus 2mx plus 2m plus 7. So with this quadratic here, we have to figure out what values of m will allow it to have 2 x-intercepts. So if there are 2 x-intercepts, we know that the discriminant is going to be greater than 0, meaning that b squared minus 4ac is going to be greater than 0. Question is, what's the a, b, and c value going to be here? So what's the a value, what's the b value, what's the c value that we're going to plug into the discriminant? Well, notice that there are 2 x squareds here that we're dealing with. And when you get something like that, what you want to do is you want to rewrite this. You want to factor out the x squared in front from these two. So you'd be left with 2 plus m over 3 x squared. So I just took these two terms here that both contain x squared. I factored out the x squared in front. You could factor out here, put the x squared here as well, but I think it's better to put it there. It just looks more like a quadratic then. And we're left with 2 plus m over 3. So if we redistribute that x squared back in the bracket, we would end up here. And then here, this 2mx, that is the only expression that contains the 1x. So we could rewrite that as 2mx. And then plus 2m plus 7, those don't contain any x's, so we can rewrite those as well. So notice that the a value is this entire expression in front of the x squared. So it's like ax squared plus bx plus c. So this is the b value, and then that whole thing is the c value. So the a value is 2 plus m over 3. The b value is 2m, and then the c value is 2m plus 7, like that. Right? So this question is a little bit trickier in terms of knowing what the a, b, and c value are. So sometimes you're going to have to do this. You're going to have to collect the x squares together, or sometimes even the x's, factor them out in front, and then whatever's left in that bracket, that's going to be your coefficient. So with the x, there was only one term that had an x, but let's say we had like 2mx minus 5x, for example. Then you would rewrite this as 2m minus 5 and put the x in front, and then the b value would be 2m minus 5. That's what would go here. But there was only that 2mx there, so we only write 2m. Okay, so hopefully that makes sense. So now we just plug all of these in here. And whenever we have expressions, we have to make sure we put them in brackets. So b value is 2m, so we'd have 2m squared minus 4. The a value in brackets is 2 plus m over 3. C value is 2m plus 7, and we have to find when is that greater than 0, like that. Right? So fairly complex here. So what we're going to do is expand everything, make it into a quadratic. So 2m squared, we distribute the exponent inside the bracket. 2 squared is 4, m squared is just m squared, so this would be 4m squared minus 4. And then what we're going to do here is we're going to FOIL. So 2m, or 2 times 2m gives us 4m. 2 times 7 gives us 14. m over 3 times 2m, this is like 2m over 1, so 2m times m gives us 2m squared. 3 times 1 is 3. Then m over 3 times 7 is like 7m over 3. We have to find when is that greater than 0. And then from here, notice we can distribute this negative 4 inside the bracket. So we'd have 4m squared. You got to be careful with the algebra here. This would be minus 16m. This would be minus what? 70, no, what am I saying? 56. 14 times 4 is 56. Then negative 4 times 2m squared over 3, this is like 4 over 1. So that would be minus 8m squared over 3. Then negative 4 times 7m over 3, that is negative 28m over 3. Still solving when is that greater than 0. Right? So looking pretty weird at this point, but nevertheless, this is a quadratic. We're going to end up getting a quadratic here. Now, notice how we have these fractions here. So if you want to get rid of the fractions, what you could do is you can multiply everything by the lowest common denominator. And then we'd have to multiply the right side by the lowest common denominator as well. Lowest common denominator between these is 3. So we can multiply this by 3, 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 and then this by 3 as well. So what would we end up with? This would be 12m squared minus 48m. Negative 56 times 3, that gives us what? Minus 168. Then over here, notice the 3's cancel out. So we're just left with negative 8m squared. 3's cancel out here. We're left with minus 28m. 3 times 0 is just 0. So we're finding out when is that greater than 0. So basically, this whole expression here is equal to this expression up top. We just multiplied everything by 3. So now we could just collect like terms. So 12m squared minus 8m squared, that gives us 4m squared. Negative 48m minus 28m, that gives us minus 76m. And this is minus 168. When is this going to be greater than 0? So I'm actually going to take that and rewrite it up here. So 4m squared minus 76m minus 168. When is it greater than 0? So this here is the simplified expression for the discriminant. And because we're solving for 2 x-intercepts in scenario 1, we have to solve when is it greater than 0. And then as I did in the previous video, when I get to something like this, I just like to graph this quadratic. I like to find the 2 x-intercepts and then find whether it's opening up or down, and then just roughly graph it and then see visually when is it going to be greater than 0. So I could factor out a 4 from everything. 76 divided by 4 is what? 19. And then 168 divided by 4 is 42. So we're solving when is that greater than 0. This here factors smoothly, which is nice. Factors into m minus 21, m plus 2. And now we can just graph this here. So what are the intercepts? Well, an m value of positive 21, m value of negative 2. So negative 2 is like here, positive 21 is here, and this is opening up because that leading coefficient is positive. So it looks something like this. And now we can visually see when is this quadratic going to be greater than 0? When is it going to be above that x-axis, or the m-axis in this case, because the independent variable is m? Well, over here and over here. So basically, when m is less than negative 2, or m is greater than 21. Does that make sense? Above the x-axis, those two places right there. And now, since we have all of this, we can actually answer these questions very easily because we're dealing with the same quadratic. So when is this quadratic going to have one x-intercept? Well, that would happen when the discriminant is equal to 0. And because this discriminant is going to be the same quadratic, we're just basically solving when is this going to equal 0. And we've graphed this already. It's going to equal 0 here and here. The y value is going to be 0, right? So basically when m is equal to -2 or when m is equal to +21, right? That's when this quadratic is going to have one x-intercept. And no x-intercepts, that's going to happen when the discriminant is less than 0. So we'd be solving here, when is this less than 0? It's less than 0 over here, that's when it's negative. So basically, in between -2 and 21, right? That's when the discriminant is less than 0. That's the inequality there. So those are your answers. So when you're dealing with the same quadratic, it's actually not bad because you could just use that same diagram, right? Just switch up the inequality, and from the diagram you could see when is it greater than 0, when is it equal to 0, when is it less than 0. But nevertheless, these are the answers for this question. So the trickiest part about this question, probably the solving, getting to this simplified quadratic was pretty tough because we were dealing with fractions. But another tricky part was putting this 2 plus m over 3 in brackets in front of x squared, basically factoring out that x squared from these two and knowing that that entire expression is the a value. And then this entire expression is the b value, this entire expression is the c value, plugging it in, and then solving the inequality.